Trigonometry for Core 2. Stuff you need to learn because it's not in the formula book is the sine rule, the area of a triangle, which is a half AB sine C. 180 degrees is pi radians, so 360 is 2 pi radians. Arc length is r theta, and area of a sector is a half r squared theta, and theta must be in radians. To find an angle in radians, I find it's easiest to think in terms of degrees, so what fraction of 180 is your angle? So for 30, you do 30 out of 180, which is 1/6, so 30 is 1/6 pi, or pi over 6. 240, you do 240 divided by 180, which is 4/3, so 240 is 4/3 of pi, or 4 pi over 3. It's really helpful if you can sketch both the sine graph and the cos graph, and remember that the sine graph goes through 0 and the cos graph goes through at 1 on the y-axis, so that you can use them to help you solve equations. Remember that the cos and sine graphs both repeat every 360, or 2 pi, and the tan graph repeats every 180, or pi. This will help you remember how many solutions you should be finding when you're solving an equation. These two triangles can be really useful because sometimes when you're solving an equation and you're working in surds and then you're doing inverse cos of something complicated, you'll get an answer with lots and lots and lots of decimals when what you want is an answer in terms of pi, for example. So if you look at this one is the unit square cut in half, so 1 squared plus 1 squared gives you 2, so that side must be root 2 using Pythagoras, and your two angles are going to be 45. So that means you can find cos, sin or tan of 45 degrees. You can also, if you've got a cos of something is 1 over root 2, for example, you know that cos is adjacent over hypotenuse, so this must be the adjacent, this must be the hypotenuse. You're talking about the 45 degree angle. Bear in mind that 45 degrees is also pi over 4. So that might help you if you're working in radians. The other one is an equilateral triangle with sides of 2, and that means if you chop it in half into 2 right angle triangles, that's going to be 1. This is going to be 60 because that's the angle in an equilateral triangle, and that's going to be 30 because it's half of the whole angle at the top there. Using Pythagoras again, we can work out that that's root 3, and that allows you to find cos, sin and tan of 30 degrees and 60 degrees really easily. And you can also do it in terms of pi, because 30 is pi over 6 and 60 is pi over 3. These are really important to learn and know off by heart because they tell you what effect your transformation or your equation is having on your graph. So it helps you to figure out, for example, if it changes the period of your graph and how often your graph repeats, you'll have an idea of how many solutions you're looking for. You also need to have learned these for the transformations of graphs chapter anyway. Let's have a look at a really complicated, frankly quite evil trig question. 4 minus 7 cos of 2t plus 35 equals 0. So we're going to solve it step by step. We're going to rearrange it to start with to get cos of something is equal to something else. So we're going to take this 4 over to the other side, it becomes minus 4, then we're going to divide by this minus 7, so you get minus 4 over 7, minus 7, sorry. So that rearranges to cos of 2t plus 35 is 4/7. Now we're going to do the inverse cos of 4/7, and we're going to get a value of 55.15. So if you look at the cos graph, you can see that that's your solution here, but there's also another solution within the 0 to 360 range, which is going to be here. It's going to be 55.15 less than 360. So we've got another solution there. So once you've done your inverse of whatever it is that you're doing, whatever function, look at the graph and figure out what solutions you've got between 0 and 360. The next step is to say that I know the graph repeats every 360, so I'm going to say if that's a solution, then this is also a solution. And if that's a solution, this is also a solution. And I can keep going. It might also sometimes be useful to take off 360 from each thing and get some solutions from before 0. If you then work through and solve each of these 4 equations, you should hopefully find you get all the solutions for t between 0 and 360. We can now check our solutions. So if we've solved those equations, you've got t is 10.1, 190.8, 134.9 and 314.9 to 1 decimal place, because that's what the question asked for. Because we've got values between 10 and 314, it looks like it covers all the values between 0 and 360. If we hadn't have added 360 to both our values in the previous step, we would only have got these 2 solutions. And that would probably have told us that if we've only got solutions between 0 and 180, 140, if we're being picky about it, that probably means we've not got all of the values that we need, and that the equation that we were using has transformed our graph in some way that it repeats more often than once every 360. That's why we added the values of 360 in, so that once it's done the transformation to the graph, we will still have all the values that we need within the range that we needed. The unit circle can be really helpful for remembering our trig identities. The radius is always going to be 1, and if you look at the angle it makes with the x-axis, which is theta here, then the opposite, or the y-coordinate in this case, is, from trigonometry, opposite is sine times hypotenuse. So you've got sine theta times 1, which is just sine theta. So this value here is always going to be sine theta. Using the same logic, this value is always going to be cos theta, because adjacent is cos times hypotenuse. The hypotenuse is still 1, so we've got cos theta here. We can then use those in Pythagoras and say cos squared theta plus sine squared theta equals 1 squared, which is our first trig identity. You can also say that tan theta is opposite over adjacent, so tan theta is sine theta over cos theta. They're your 2 trig identities. For further maths people among you, bear in mind when you're doing general solutions to trig equations, in the step where we added 360, you would add a line to your equation that says plus 2 pi n, and then continue to solve, and that should give you the general solution. Bear in mind, if it's sine or cos, it's plus 2 pi n, and if it's tan, it's just plus pi n. Hopefully that's given you a good idea of everything you need to know for trig, and answered any questions that you've got.